Okay, so we have this data. Our data would be office workers. There are 20 participants, 10 males and 10 females. The researcher got their height, the IQ, then the performance, their performance before they conducted a training. And then they put that also in a scale type using this scale. 1 for poor, 2 for satisfactory, 3 for good, 4 for very good, 5 for excellent. Now, the performance after was recorded also after the training. Then, the performance after using a scale. Okay, so we go to our SPSS. Then we click the variable view. We go to the names. Make sure that if you click the names, if you are going to type here, there will be no spaces. So, office workers. Next one is the gender, followed by the height in centimeter, then the IQ of the workers, performance before of the workers, then their performance before using a scale. Next is the performance after, then their performance after using scale. Okay, so we go to the label. In this label, you can retype all of this. This time, you can use space. Office space, workers. Then gender will stay as a gender, including the height. You can say in centimeter. Then the IQ. Then performance space before. Next, performance before using scale. Then performance after. Then performance after using scale. Okay. Now we go here to gender. Since we have two types, we have male and female, we are going to put values for the gender. So you click, then you go to values. 1, that would be for male, then click add. Then next, 2, that would be for female, then we click add. Okay, so in here, if you notice, we can use 1 or 2, or you can use any other number to any other number to represent male or female. It can be 0, 1, 1, 2, 2, 3, and others. And then we click OK, meaning we coded 1 as male and then 2 as female. Then we go to the different measurement. If we talk about office worker, that is nominal. We talk about gender, that is nominal. Then we go to the height, that is in the form of scale. The IQ is in the form of scale also. Then performance before, that is ordinal. But if we are going to use scale, the performance using a scale, we use scale. Then this is ordinal, and then this is scale. So having that, if we have typed that already, we can now go to our data view. Okay, so notice that everything that we have put in our variable view appears in our data view here. Now, we are going to go back to our Microsoft Excel. Then we can just copy. Control C. Then we go back to our SPSS. we click there, Control V. So as you notice, our gender is 0.00 because we the application will not read male or female. Rather, we put there. So male, use just one. Okay, I think one is better. One. And then females, sorry, 2. There. 2. Okay, so if you click this will become 1 and 2 using our code. And if you click the back again, that will be for male or female. Now, we are done with our encoding, data encoding. We go then to our steps in hypothesis testing. Is it safe to say that the average height of the office workers is equal to the average height of the people in the Philippines, which is 156.41? Okay, so 156.41 according to studies, that is the average height of the Filipino people. So we are comparing the average height of the Filipino people to the average height of the office workers. Start with the first one. How are we going to formulate the null hypothesis? For the null hypothesis, there is no significant difference between the height of the office workers and the average height in the Philippines, which is 156.41 centimeter. And for our alternative hypothesis, all we have to do is negate the null hypothesis. So there is a significant difference between the height of the office workers and the average height in the Philippines, which is 156.41 centimeter. Now we are going to choose our statistical test. This is a one sample t test. For the one sample t test, how are we going to compute that one? We go back to our SPSS. Okay, so since we are here now in our SPSS, we click Analyze, we click Compare Means, and then we click One Sample T-Test. Okay, so our first problem is we are going to get the height of the office workers. Then we click the arrow. Then we put here the option 95 for 0.05 critical value. Click continue. Our test value, the average height of the Philippines, which is 156.41. Okay. Again, we put our test variable as the height in centimeter. And then our test value is the average height of the Filipino people, which is 156.41. And then we click then OK. So this is now our data. So one sample statistics is showing that we have 20 samples. Then the mean of the sample is 159.6335. And then this one sample test shows the inferential statistics. So our DF is 19, which is 20 minus 1. And then the mean difference is 3.22350. This is the mean difference of our sample to the average height of the Filipino people. But we are testing if there is a significant difference between the two. So since our significant value or our p-value is 0.019, which is lower than 0.05, we can now have our decision and conclusion. So we copy this, Control, then click this one, Control C, or we copy. Then we go back here. For our computation, we paste. Okay? So for the computation, we have here this. Okay, so we go now then to our decision. So our significant value or p-value is 0.019. So since the computed p-value is 0.019, which is lower than the critical value, which is 0.05, then how are we going to do this? We reject the null hypothesis. Okay, so since we rejected the null hypothesis, we are going to accept then the alternative hypothesis. So our decision, there is a significant difference between the height of the office workers and the average height in the Philippines. So as you notice, the mean here is 159.6335, which is higher than 156.41, meaning we can say that there are people in the office that are way taller than the usual height of the Filipinos. So that would be for the one sample test. Next example, is the average IQ of the office worker significant to the hypothesized mean of 100? We are going to formulate first our null and alternative hypothesis. So for our null hypothesis, we can just say that there is no significant difference between the IQ of the office workers and the hypothesized mean of 100. If that is our null hypothesis, we just negate our alternative hypothesis. We can say that there is a significant difference between the IQ of the office workers and the hypothesized mean of 100. So choosing the statistical test, that is one sample t test. Then we go back to our SPSS for computation. So this is our SPSS. We go then to analyze. We go to compare means. One sample t-test. So we return this back. Then we change our test value into 100. Okay, and then the IQ, since we are testing IQ, that would be the one to be put here. Okay, IQ, then 100, then press OK. So we have here our one sample statistics and then the one sample t-test. So we highlight this, then copy. We go back to our Microsoft Word, then we paste it. Okay, so here, analyzing the table, the mean of the sample is 99.9000, which is very close to our hypothesized mean of 100. And then, the mean difference is negative. Okay, negative 0.10000. Now, this is our concern for us to know if there is a significant difference between the two. Since our significant figure is 0.950, which is way higher than the critical value of 0.05, we can now have our decision. Since the computed p-value is 0.950, which is higher than the critical value of 0.05, then what would be our decision? We are going to accept the null hypothesis. So since we accepted the null hypothesis, our conclusion will then be there is no significant difference between the IQ of the office workers and the hypothesized mean of 100.